I'm Anil Kumar. Welcome to my series on SAT. Now, in this particular video, we will teach you how to crack SAT and that to level 2 for any question related to vectors. So, with one example, I'll teach you all the concepts, and I hope that works for solving any SAT question. What we need to understand about vectors is how to find magnitude of a vector, how to find unit vectors, how to find sum and difference of vectors, how to find angle between vectors, how to find dot product, and how to find perpendicular vectors. So once you understand these 6 concepts, you can actually solve all the questions for SAT or equivalent test papers wherever vector questions are involved. So we have taken a very simple example here. The idea here is to understand the concepts, and believe me, the questions which you are going to get in especially SAT will not be more difficult than this. Let's review the very basic concepts. We know what are vectors. Vectors basically have magnitude and direction. Correct? So if I say that I have a vector u which is written as, let's say, x and y, so these are the coordinates. In that case, we can say that the magnitude of vector u is basically equal to square root of x square plus y square. Right? And if we want to find unit vector, in that case, unit vector for u will be equal to the magnitude, whatever we have, we can say the vector u, which is xy for us, divided by its magnitude. So that becomes a unit vector. Now at times, unit vectors are written as coordinates divided by this, or you may just be given a formula to write. Then what else we need is what is the dot product. So if I have two vectors, let's say vector u and vector v, if we want to find the dot product between the two, then the dot product is magnitude of u times magnitude of v times angle between them. So that is the formula to be used when the angle is given to us. And if not, in that case, we can say that the dot product between the two vectors will be, let's say x1, y1 and x2, y2 are the coordinates. Then it will be x1, x2 plus y1, y2, right? It is always a scalar quantity which you can get. Now, you also realize that to find the angle, what we could do is we could rearrange this particular formula and find angle by finding dot product and dividing that by the magnitude of u and v. Is that clear? So that actually gives you cosine of theta. So you can find cos theta as inverse of this, right? So from here we get, say, theta is equals to cos inverse of dot product over the magnitude. Is that okay? So these are the formulas which can help you solve the above questions. Now what are we given here? We are given two vectors OA and OB. Now whenever we start vector from the origin, we call them position vectors. Correct? So vector A, which could be written as OA, here is also written as vector A, is basically equal to 3, 4. Right? So that becomes 3 minus 0, 4 minus 0 gives you that position. Vector OB is the vector B for us, right? Which is 12, 5. So this information is given to us. We are going to use this information and find or see how to calculate the magnitudes, unit vectors, add and subtract vectors, find angles, use dot product, and find perpendicular vectors. Perfect. So that's what we'll do in the coming examples. So we'll work with the same example. Let's see how to find magnitude first. So we'll find magnitude of OA and OB. So vector OA is given to us as 3, 4, right? So magnitude of OA is basically equal to square root of 3 square plus 4 square square root, which is equal to square root of 9 plus 16, which is 25, and that gives you 5 as your answer, right? So that becomes the magnitude of OA. Now if I want to find unit vector for A, that is OA, then it should be what? I have to divide the vector OA by its magnitude, right? So that is to say, I will divide 3, 4 by 5. So I get this. So I can say that the unit vector for me is 3 over 5 and 4 out of 5. Is that clear? So that becomes the unit vector. Is that clear to you? Now with this in mind, I would like you to do the same calculation for vector B, which is OB, right? So once you're done, then look into my calculations. So we are now finding what is vector OB magnitude equals to, right? So the magnitude will be square root of 12 square plus 5 square, which is square root of 169 plus 25. 144. Square root of 144 plus 25, which is square root of 169, which is 13. Now these are special triangles, right triangles, as you know. These are Pythagorean triples. So when you're going for SAT, you should know Pythagorean triples. So that is a key, right? They help you in solving many equations, right? For example, we have 2 here. One is 3, 4 and 5, correct? The other one which we are working with is 5, 12 and 13. Okay. So we know that the magnitude of OB is 13. So what is the unit vector? Let's write unit vector. OB. So that is normally represented by this cap on the top, and that would be 1/13 of the vector OB, which is 12, 5. Is that clear to you, right? So the unit vector is this. Preferably, you should write this unit vector, let me write here, as 12 over 13 and 5 over 30. Is that clear? So that is how you can calculate the unit vector, correct? Now as an exercise, what you can do here is, you can find what vector C is, and also you can find what is the unit vector C, right? So that will be an exercise for you, okay? So let's move on and take up the next question. Now let us see how to find vector sum and vector differences. We'll again use the same diagram which we have. We have vector OA and OB. Vector OA is given as A and vector OB is given as B. So let us find what is the sum of, let's say 2 times A plus 3 times B equals, right? Let's say that is the vector sum which we want to find. So let this be the first question for us, right? Now how do we do it? Now let me write down these coordinates in Cartesian form. That is to say, I can write vector A, let me write down here, vector A can be defined as 3i plus 4j, where I and j are unit vectors along x and y axis. Is that clear? Vector B can be written as 12i plus 5j. Is that clear? So these are the vectors in Cartesian form which we will use, and we'll use vector algebra to find the addition. So when I say 2 times A plus 3 times B, it basically means 2 times, well, we'll do it in this form, matrix form. So that is straight, which is 3 and 4 will write for A, since I just drew this, plus 3 times vector B. This is faster and easier actually. You will also, in test paper, do in this fashion. So you just multiply the inside things and add them up. So you get 2 times 3 is 6, plus 3 times 12 is 36. You get an idea. 2 times 4 is 8, plus 5 times 3 is 15. Correct? Now you can add this up. So you get 42 here, and you get 23 here. Correct? So that becomes the answer for 2A plus 3B. Correct? Let's do some difference now. We can just take any variety you want. So let's do this time, let's say 2A minus B, right? So let's do this. So we are going to use ij this time. So it is 2 times, we'll use the vector 3i. There's another way of doing the same thing, minus 12i plus 5j, just to give you some practice, right? So that gives you, so you have to combine the i's together and the j's together, like terms. 6i plus 8j. Now I, j, k are your unit vectors, right? So that is how we give unit vectors. Minus 12i minus 5j, correct? So 5i minus 12i is minus 6i. And 8j minus 5j is plus 3j. So that becomes the difference between twice the vector A minus B. So we have also seen here scalar multiple, right? So we have seen a concept with scalar multiple. Is that clear to you, right? So that is how we could do vector addition and subtraction, and these are the 2 ways to do it. In the following part, we'll see to find angle. How do you find angle between vectors? So that I will take up as a next part. Now here, just to practice, let me give you a question. Let's say question for you now here is, you find what is 3b minus 2a equals to, right? So calculate this. You can use either of these methods. The idea to show you the matrix is that this is a much simpler method to use, and in test it helps. Perfect? Okay. Now let's take up the next part of it, which is basically how to find angle between vectors. Okay. Now to find angles, we could use cos, that is dot products, right? So if there are 2 vectors given to us, then A dot B is basically equal to magnitude of A times magnitude of B times cos of theta. So you can always rearrange and write cos theta as equal to ratio of their dot products, okay, to their magnitudes product. So that is what cos theta is. So to keep things simple, what we will do here is we'll find all these angles. Let's say we first find this angle. Let's call this angle as alpha. Okay. So how do we find this angle? So here cos alpha will be equal to, these are the 2 vectors A and B, right? So it is A dot B divided by the magnitudes of A and B. Correct? A dot B. Vector A is 3, 4, dot 12, 5. The magnitudes are 5 and 13. We found earlier, right? This is 5 and this is 13. So we have 5 times 13. Correct? So let's calculate the dot product. So 3 times 12 dot product, right? So it is, so let's write like this in steps, plus 4 times 5 over 5 times 13, right? So that gives you 36 plus 20. Or we'll use calculator to find this. Okay. So basically 56 over 65. 5 times 3 is 15 and 65, correct? So what is alpha equals to? So alpha is equals to cos inverse of 56 over 65, correct? So we have shift cos inverse 56 divided by 65 equals to 30.51. Let's say 30.5 degrees. So we got one of the angles which is equal to 30.5 degrees. Right? Now, to find other angles, you can actually use cosine law. Correct? So we got dot angle. Let's work with all combinations. Right? So if I have to find this angle, let's call this angle as beta. In that case, we can say sine beta over the side opposite is 5 units should be equal to alpha, which is we just found sine alpha over C. Well, we didn't find magnitude of C, so let's find magnitude of C also, right? Okay. So let's find magnitude of C. We'll write magnitude of vector C. Okay. So first, let's calculate what C is. I'll do it here. I thought we did it earlier. So vector C is basically 3 minus 12, right? And 4 minus 5. So 3 minus 12 is minus 9 and 4 minus 5 is minus 1. So this magnitude of C is basically square root of, we can write 81 plus 1, which is square root of 82. Is that clear? So we'll use sine of 30.5 over magnitude of C, which is 82 square root. Clear? So from here we can find angle beta equals to what? So this will be 5 over square root of 82 times sine of 30.5. Correct? Let's use calculator. So we'll do sine of 30.5 equals to multiply this by 5, divide this by square root of 82. And what we get here is, this is sine beta. Let me write down first sine beta. We'll do sine inverse later. 0.28024, right? So beta is equals to sine inverse of all this, 0.28024. So we'll do sine inverse now. Sine inverse of our answer is basically equal to 16.27. Correct? So we found that angle beta is 16.27. Is that okay? So we have found this angle, the other angle, the third angle at A, which you could always write angle OAB is equal to 180 minus 16.27 minus 30.5. Correct? So the whole triangle has been solved. So we'll do this. We'll do 180 minus 16.27 minus 30.5, which is 133.23 degrees. Correct? Now these angles could be rounded to whatever figures are mentioned in the question, correct? But I hope by this you understand how we can use dot product, correct, to find the angle between vectors. Perfect. So we have now learned how to do addition, subtraction, and now how to find the angle between the vectors. So now, as an exercise, what you can do is you can get back to your previous question. All these vectors which we worked with, you can find the angle which they make with the horizontal, for example. You could do that, right, as a practice question. So I hope that is perfectly fine. So let's move on and take the next question, which is basically to find the dot product, which we have already done, right? Since we have already found the dot product and we also calculated this angle and we rounded to 30.5, correct? Now, what we can do here is, since it is a learning process, we can find dot product using geometric method and algebraic. Correct? Since we know the angle now between vectors A and B, you get the idea, right? So both you should be good at. So geometrically, let's find A dot B. So geometrically, we'll use these two. We know the magnitude of A is, let's write down here. The magnitude of A is square root of 3 square plus 4 square, which we know is 5. Magnitude of B is 12 square plus 5 square, which is 30. Okay. So we know A dot B should be equal to magnitude of A times magnitude of B times cos of angle between them. So the magnitudes are 5 and 13. Cos theta is 30.5. So we say cos of 30.5 degrees. Is it clear? So let's calculate. What do we get? So we get 5 times 13 times cos of 30.5. That gives us 56.00. So we'll just write 56. Is that clear? Now algebraically, if I have to find A dot B, how do we get it? We know their position vectors 3 and 4, dot 12 and 5. Right. So that gives you, no need. So we get 3 times 12 plus 4 times 5, which is 36 plus 20, which is also 56. Do you see that? So it is in a way confirmation that all our results are correct, both the formulas work, and you should not be hesitating in using any one of these. Correct? So that's the whole idea. Now, question for you is to find dot product between C and A and between C and B, right? So that will be a question for you. What is vector C? Let me write down vector C for you. Vector C will be 3 minus 12, which we wrote earlier, which is minus 9, and 4 minus 5, which is minus 1. So that is vector C for you. So as a practice, you need to find dot product between C and A and C and B. Correct? So you can do this exercise. Once you have done this, then find angle ABO. Is that clear? So you have to find angle ABO. So you have to do exactly what we did earlier, or you could use this formula. So you can find the dot product using the algebraic method. An angle between these two vectors you can find using the other formula. Remember the directions. So O to B is kind of like this, right? And vector C is in this direction. So the angle which you are going to find is when they are placed tail to tail. So you are looking for an obtuse angle here. So that is a hint, okay? So it's a very important exercise. Try to do this. Post your questions in the comments. Fine. Let's see the last part now. Now here, the exercise is to find perpendicular vectors. So let us say that vector u is perpendicular to vector A. That means what? That means that vector u dot vector A should be equal to 0, right? Now how do we find perpendicular vectors? It's a very easy step, especially when we are working in R2. Vector A is given to us as 3, 4, right? So you could write vector u as, reverse this, swap, right? And change one of the signs. Will be 4 minus 3. Perfect. So that becomes a perpendicular vector. Now you would like to check it, of course. So let's check. So the vector u dot vector A is what? Let's check this. So u is 4 minus 3, and we are doing dot with A, which is 3, 4. So 4 times 3 is 12. Let me write here 4 times 3 minus 3 times 4. What do you get? 0. So if the dot product is 0, the vectors are perpendicular. So that confirms perpendicular vectors. Is that clear? Similarly, for a vector, let's say v is perpendicular to vector b. In that case, vector v will be equal to, this is 12, 5, right? So I'll just change this to 5 and make one change in sign. So 5, 12. Is that clear? You can check that if I do dot product between 5 minus 12 and 12, 5, what do I get? I get 5 times 12. 60 I wanted to write. Okay, 5 times 12 minus 12 times 5, which is again 0. So the idea here is to get the perpendicular vectors. If I am given a vector A as equals to, let's say, xy, then the perpendicular vector will be what? Let's say u will be y minus x. So that is straightforward. So you can easily find perpendicular vectors by swapping x and y and changing one of the signs. Is that clear to you? So now let us summarize what we did here. So we just took one simple example. This was a good example since we know 3 square plus 4 square square root is 5. So we know this magnitude is 5. 12 square plus 5 square is again a whole number. So this was 13. And using this, we found a plus b and all those things. We also found the unit vectors by dividing the magnitude, which is 5. So 3 over 5, 4 over 5 becomes unit vector, right? So here the unit vector will be 12 over 13 and 5 over 13, right? So the unit vector of B was found to be 12 over 13, 5 over 13. Does it make sense to you? Right? We found vector C as difference of these two, and we found that vector C was basically equal to minus 9, 3 minus 12, and 4 minus 1 minus 1, correct? Which magnitude was square root of 82. We found this angle to be 30.5 using dot product, and we applied sine law to find the other angle, correct? So with all this, we could actually understand how to find magnitude of a vector, a unit vector. We could do different combinations of vector sum and difference. We could find angle between any two vectors. Now in any two vectors, it is important that the vectors should be placed tail to tail, right? So in our case, if they are like this, the angle could be obtuse, right? So important, tail to tail. To find the angle theta between vectors. Is that clear to you? So that is kind of very important. For perpendicular vectors, we got a rule, and that is if I have x, y as one vector, the other will be y minus x. And these vectors are always perpendicular. We are working in R2. So as far as R2 is concerned, we have understood all the concepts. I hope that helps you to crack SAT without difficulty and take up any test of that level. Feel free to write your comment, share your views. If you like and subscribe to my videos, that will be great. I'll give you some practice questions on vectors with multiple choice as you normally see in SAT. That should further help you to practice and get better scores. Thanks for watching and all the best.